Hello and welcome to Textbook Engineering Problem. Today we're working out of Elementary Principles of Chemical Processes, 3rd edition. We're going to be working on problem number 2.44. It's a computer problem. I'll read the problem statement. Write a computer program to fit a straight line y equals a times x plus b to tabulated x, y point data, assuming that no more than 100 data points will be taken in any one run. Your program should read in and store the data, evaluate the slope A and intercept B of the best line through the data using equations A.1-3 through A.1-5 in Appendix A. Then print out the measured values of x and y and calculated values of y equals a times x plus b for each tabulated value of x. Test your program by fitting a line to the data in the following table. Let's move over to the computer. Let's use Python for this. Okay, so here I'm using a new program instead of using a spreadsheet program, which you could do in Excel. You could use VBA, but I thought I'd use a different program to write this one because I think it will be a little easier to write. Okay, so I imported this NumPy library because it helps deal with arrays, and we're going to be using a table and array of points basically. So that's what this import statement is. Then I make a function here that's called fitLine because that's what they want us to do, is to fit a line to a certain input data that we're given. Okay, so I'm going to store all of the x values in this function by taking the input data points and transposing it, and then grabbing all of the x values from there, which are going to be stored in position 0, which is the first position. And then I'm going to get all of the y values and do the same thing by transposing that data set and grabbing all of the values in the second position. Okay, then n is the length of that however many data points that we got. So in the problem statement, they said, assuming that no more than 100 data points will be taken in any one run. Well, we don't have to assume that there's 100 data points. We could have, 1 million data points. It doesn't matter. We just enter in the data points, and then we can calculate how many spots there are just by looking at how big the input is. So yeah, there you go. That's what n is. Okay, so then we go to Appendix A1 and we calculate SX, SY, SXX, and SXY by using these functions that we were given. And then we calculate the slope from Appendix A and the intercept from Appendix A, and then y fit equals a times x plus b. So then we return x, y, and the fitted point for that same x value. I think that, so it says then print out the measured values of x and y, so those are the measured values, x, y, and then the calculated values, so that is y fit is the calculated value. Okay, that's the end of our function. So now we're saying, okay, data is what they gave to us in the table. Then we call our function. The answer is equal to fitLine, and it's reading this data here. So then it goes through and calculates x and y, how many data points there are. Then it calculates the intercept and the slope based off of the Appendix A1 function, and then it spits out all the lines, and then we print our answer. Okay, so then we print out the output of this function. So we should have 3 arrays. We should have our x array, our y array, and then our y fit array. Okay, so our x array is 1, 1.5, 2, 2.5, and 3, and that was our input, so that's perfect. Then we've got our y function here, and 2.35, 5.53, 8.92. Yep, so that matches. That's all of our y's right there. And then this is our y fit. And that is one way to write the function that they asked for in problem number 2.44. If I know this is a short video and I didn't write the function right in front of you, but if you're familiar with Python, this should make sense. If you're not familiar with it, it's a pretty easy language to pick up, and it's used very frequently. So if you're interested in continuing in engineering, you really should learn the Python language. And there's plenty of documentation online for you to be able to do that. But yeah, here's a quick introduction of how you could write a Python function. Great, thanks for joining me. If you have any questions or comments, please put it in the comment section below. And if you need any help on any other problems from this book or another book I'm familiar with, just let me know, and I will respond to you in the comments, and we'll see if I can help answer that there, or if we need to make another video, that's fine too. Thanks for joining me. I hope to see you in the next video. Thanks. Bye.